So please download the slides, because there are also hidden slides in our deck. When we jump into some of our demos, the hidden slides have got screenshots in there for when you download them.
Yeah, and if we don't have time for questions, we're going to be here after the presentation. Please come through and, ask us anything you like. So I guess we've got to start with obligatory 30,000 feet slide. Why do we want to do network access protection? What is it? It's a mechanism by which we can isolate devices that don't meet configuration criteria that we set. We want to do that because machines that don't have the latest Windows updates may be jeopardizing our connection. They may be infected with Trojans that machines that have the latest virus signatures can clean themselves. So if you don't have the latest virus signatures, you may impacting our environment. And also, if from a compliance perspective, you need all your machines to be up to date from a Windows update service specs perspective, NEP is one way to enforce that compliance. How do we do that? By deploying a NEP client, or by enabling a NEP client which is already built into Windows 7, which allows us to enforce certain aspects of the configuration of Windows. And we'll go through configuring that client and make it tick. One aspect of NEP is not only the enforcement of configuration, but also remediating the client as well. So let's jump into a quick demo, and we'll show you a remediation option. Done one. I knew I was going to get it wrong. So this is a Windows 7 client machine, and so usually when we do the demos, I'll do the demos, Daniel would talk, but in this case...
Just making sure you can see it all right. That doesn't look too bad.
So I've got a Windows client here, and I'm the administrator. So just to show you that NEP enforcement and remediation works on administrators as well. And I'll decide that I don't really want my firewall on, and I'll go in and try and turn that off.
Who needs a firewall running, right? It just gets in the way.
So I've turned my firewall off, and if you blink, you've noticed that my firewall was beginning,
So what's happened there? We've turned our firewall off. We've become unhealthy. NAP's gone, I need to go and check my health state. It's sent to health back it out. It's come back and said, no, the firewall has to be on, and it's auto-remediated. So it's turned the firewall back on, and our health state has gone back to healthy again. Can you slow that down, Rand, so people can see that again?
Yeah, so this corner here is the NEP client as well, or the balloon that pops up when the machine is compliant or non-compliant. So to slow things a bit, let me go to the services console and let me disable the Windows Firewall service.
Now, I prayed to the demo gods this morning. I hope you said you had a rubber chicken you were going to do something with.
I had a rubber chicken, but I left it on the plane, so... So hopefully there's Air New Zealand don't have any issues with a rubber chicken on a plane. So we're trying to stop. Obviously, the NEP client is objecting very hard for us doing that. We may lose connectivity to the machine because it's going to lose connection to the network. But if it comes back, you'll see that our client is actually disconnected from the network because it's not compliant. You can try and connect to it via the good old way. Let me quickly log on to it.
So this is the one we prepared earlier, right, Rand?
Yeah, that's the one we repaired earlier. So as you can see now, my client is unhealthy. It doesn't meet the security standard because the firewall is off, and it's been disconnected from the network, as you saw in the demo.
So our certificate's been revoked. We can no longer make IPsec connections to servers which have got secure or isolation IPsec policy applied. And we're going to go over all that terminology as we go through. I just wanted you to have some screens in your mind as we were talking so you could match them up. Yeah,
I'll put the firewall service back in automatic mode, and the NEP client will will restart the service and will enable the firewall for me. Just to speed things along, I'll turn on the firewall service, and the NEP client will turn on the firewall and will make will change the state of the machine to compliant. There we go, we're back to compliant again. And now we can get full access to our network.
Right, so that's just a bit of a taste. Let's jump back into our presentation. Right, so just to recap, we're going to be talking about NAP with IPsec enforcement. So we're going to be talking about issuing certificates and IPsec policies. But there are also other enforcers. There's DHCP, VPN, and 802.1x. Why NAP with IPsec? Because we can overlay that on any network infrastructure, and we don't have to make changes to the underlying network infrastructure or networking equipment to be able to support it. We also have a function called IPsec with null encapsulation, which we'll cover as well, which essentially says we can authenticate connections, but we don't send that traffic encrypted.
From an IPsec point of view, this is what makes NAP with IPsec tick. It's a bit big, but don't worry about it. We'll go over the components bit by bit. On the left-hand side, so your left-hand side, actually it's my left-hand side too. Hey, bonus. We have the client component. So the network access protection client composed of multiple system health agents, which look after different aspects of the client configuration. The system health agent talks to a quarantine enforcement client, which we enable or disable based on the type of NAP we want to enforce. So we have different enforcement clients for IPsec, VPN, DHCP, etc. The quarantine agent is the broker between the system health agent and the quarantine clients. On the right-hand side, we have the policy server, which is made of different system health validator for the equivalent or respective system health agent on the client side. With Windows, we get out of the box the system health agent and the system health validators that manage and understand the configuration of the Windows Security Center. So that covers the Windows firewall, any compatible antivirus and anti-spam agents, and Windows Update as a whole.
But the NAP architecture has been opened up as well. So there are lots of other vendors which have written agents and shivs that clip into the Microsoft NAP infrastructure and utilize that. A lot of AV vendors have done that. We also have config manager integration as well, which is what we're going to be using for our patch compliance enforcement.
Yeah. In the middle, we have the Health Registration Authority, which is a broker between the client and the agent. And we use that for IPsec because we don't want to allow our clients to connect directly to our network policy server, which usually sits in the isolation zone. So the edge array is the component that accepts connections from the client and passes the connection request to the network protection server, And the edge array is also the component that provisions certificates for the client so they can establish the IPsec connections.
All right, so we kind of know how NAP works now, but we've got the other side of that, which is the IPsec. So there are a couple of terms that we talk about when we talk about IPsec. We talk about these isolation zones, and we talk about these boundary zones. So servers in our isolation zone are configured with an IPsec policy, which is set to require all inbound connections to be authenticated or encrypted via IPsec, and to request outbound connections. Servers in our boundary zone are set to request inbound connections and request outbound connections. The other important concept here is that these are logical zones, not physical zones. So we can have two servers on the same network segment in the same subnet, but one has got an isolation policy applied to it and the other's got a boundary policy applied to it. We configure this using group policy, and we use our system health certificate to create those IPsec connections. And when we remove that health certificate, we can no longer create the IPsec connections any longer.
So IPsec, take a step back. IPsec is a security protocol that is implemented in Windows, which allows us to encapsulate and potentially encrypt connections between two endpoints. So with IPsec, we can decide where we want to only authenticate or enforce an authentication between those two endpoints, or authenticate and encrypt the data between those two endpoints. So when we come to create those IPsec connection or configuration in the Windows firewall policy, we need to determine the source and destination IP addresses, the protocols and the ports that we want to apply that connection on, and what the authentication mechanism by which we want to authenticate the clients. So we can be quite granular in terms of which service we want to apply those connection rules on. It's obviously, I said, policy-wide, and with Windows 7 and 2008 R2, we support null encapsulation because, Daniel?
Right, well, as we talked about, if I'm suddenly encrypting all of my traffic with an IPsec, and I've got an infrastructure which has firewalls in front of all of my servers, I've got IDM, I've got IPS, that effectively makes that blind to all of that traffic. So for a lot of organisations, they already have security around their network. They want to be able to see inside that traffic. So with null encapsulation, we don't even do AH headers. The whole traffic goes unencrypted just like it normally would. The firewalls see connections going through the normal ports, the normal protocols, but we authenticate the traffic with an IPsec connection. So every time we connect, we authenticate via IPsec, then send the traffic in clear text. The other thing you've got to be careful of is some networking equipment, older stuff now, doesn't have the same throughput with IPsec traffic as it does with UDP and TCP traffic. So you have to be careful that your network's going to be able to support it. Also, when you're double encapsulating traffic, if you've already got a VPN connection and you're putting your IPsec on top, you might be double encapsulating that traffic and you're going to get a slowdown and reduced bandwidth. So null encapsulation isn't just about being able to see the traffic. It may be that you're handling the encapsulation or encryption of your traffic at a different layer, and you don't want NAP to do that for you.
Yeah, so null encapsulation is completely valid implementation. There's an RFC for it, although some security specialists reckon it was written on April Fool's Day. Because really, from a security point of view, what's the point of having IPsec if the data isn't encapsulated? But you know, the traffic is locally to our domain. We fully trust the clients. We just want to enforce their configuration, and that's one way we can do that.
So people talk about authentication. That's really what they're talking about, authenticating the client.
Yeah. So
let's talk about the components. Right, Windows 7 Vista 2008 R2. Windows 7 2008 R2 support null encapsulation. XP Service Pack 3 is also supported, but we don't have it on this slide because there's some slightly different configuration you need to do for it, and we haven't used it in the setups that we've been doing. So,
and also it doesn't support null encapsulation.
That's right.
So only Windows 7 and 2008 R2 servers support that. From a server point of view, the minimum infrastructure configuration you need is group policy, obviously, to affect the client configuration and the IPsec isolation policies. You need the PKI infrastructure, so you can deploy those health certificates to your clients and to your servers. You need the network policy servers and the health registration authorities in place so the clients and the machines can communicate with them. On top of it, if you want to supplement your NAP environment with additional shivs, etc., you need to put those in place. So in our solution, we deployed Configuration Manager. We use the Config Manager shiv to force some additional Windows updates to be evaluated for NAP. So we need to have the system, the Config Manager environment in place to be able to do that. We also provide a remediation website. So when the client gets a pop-up that says it's not compliant, they click on a button and they get to a nice website which explains to them what's going on. They can get some information on where to go to get their other Config Manager client up to date or the antivirus agent up to date if the system hasn't been able to do the remediation automatically. From an operations point of view, you can use Ops Manager to monitor your servers and understand which clients are non-compliant and if there's any issue with your certificate infrastructure and network policy servers.
Okay, so from a group policy point of view, what do we end up with? We end up with a NAP client configuration policy. We end up with a health exemption policy and an IPsec policies. So the health exemption policy, what's this all about? A lot of businesses don't want their servers to become unhealthy. They don't want their servers to be running NAP policies and to have to go and get certificates. You don't necessarily patch your servers at the same cycle as your clients, and your servers aren't necessarily at the same risk as your clients. They're not going out onto untrusted networks. So what we do is we allow servers in our health exemption policy to go direct to the CA, which is issuing our health certificates, and request a certificate from the CA. Now, why does the server need a certificate? Because if that server wants to communicate with a server which has got an isolation policy, it has to have a health cert to be able to create an IPsec connection to that policy. So essentially, we allow these servers to bypass our NAP infrastructure, get a long life health certificate, and then they can create those IPsec connections. So Health Registry Authority, and I actually think we called it Registration Authority.
It is a registration authority.
Yeah. Basically, it's a broker. The client connects to our HRA brokers that connection, it turns it into a radius request, sends it to an NPS server, which evaluates it. The NPS server responds with a statement of health response. If it's healthy, the HRA then connects to the CA and issues a certificate to the client. The certificate the HRA issues is a very short-lived certificate. So, certificate authority. It can be a standard or enterprise CA. We recommend that it's a sub-CA, and we also recommend that it's a dedicated CA. And we recommend that for two reasons. You're going to issue a whole heap of certificates from the CA. Clients don't wait for their health cert to expire. They request a new health certificate every time they reevaluate their health status. So you end up generating a lot more certificates than you potentially think you're going to. The other reason is the HRA manages the issuing of certificates and the removal of certificates from that CA. To do that, the HRA machine account has to essentially be an administrator of that sub-CA. So if you've got other certificate templates on that CA, the HRA can potentially issue those certificates as well. So your PKI guys, if you're larger, they're probably not going to want to have other health certs sitting on there. Now, you may not also need to protect the private key with a hardware security module because the certificates are such short life, and depending on how you're using your NAP infrastructure, you may be able to save yourself a fair bit by not having some pretty fancy hardware there.
Yeah, and that's the reason also why we don't perform CRL checking, because the certificate lifespan is fairly short. We don't worry about it. The network policy obviously sits in the middle of this infrastructure. It contains all the configuration policy that we want to apply to our clients, and those policies are evaluated by the statement of health validators, which needs to be installed for each component that we want to evaluate. So out of the box, the Shiv that come with the NPS server looks after the Windows Security Center, as we said before. And when you deploy Configuration Manager, you need to deploy the Config Manager System Health Validator on your NPS server. When the NPS server gets the statement of health from the client, it evaluates that configuration and returns back to the client the system of health response that says, yes, you're healthy, you're good to go, or you're not healthy. If we're healthy, the HRA provisions the certificate for the client. If we're not healthy, the statement of health response provides the list of remediation server for the client to go and get remediate itself, or an action that needs to perform. In a config manager perspective, that action could be go download the latest config manager policy from your management point and act upon it. So the remediation servers are a list of servers that the client, as we said, can connect to automatically and get remediated. And we can control which remediation servers client connect to based on where they're coming from. So we have groups of remediation server, depends on the location the clients connect to make sure the connection is speedy and the remediation is quick.
Right, we're going to have to start stepping up a bit, Ran. We're behind time already.
No worries.
So, boundary components and isolation components. Essentially, we only want to put things in our boundary zone that unhealthy clients need to connect to. So in this case, it's our HRA and our remediation servers. Now, we've got AD and DNS up there as well. You have to keep those in your boundary zone, but they're not necessarily part of your NAP infrastructure. Isolation components is everything else, NPS, CA, Shivs, system health servers. We don't want unhealthy clients to be able to connect to servers that they have no need to connect to. It's just a risk. So we're going to have to talk about the traffic flows, and this should reinforce what we've been talking about.
Yeah, so we've got a client. The client connects and sends its statement of health to the HRA, which passes it on to the NPS. The connection to the HRA is on HTTP or HTTPS. The connection from the HRA to the NPS is using Radius. The NPS evaluates the configuration and sends the statement of health response back to the HRA. If the statement of health response says healthy, the HRA then connects to the CA, gets a certificate, and passes it on to the client. The client can then use that certificate to initiate IPsec connections to servers in our secure zone.
Right. So how do we make this resilient, and how do we scale this infrastructure out? Well, our clients can be configured with multiple HRA servers that they can be configured to connect to in a prioritised order. Our HRA can be configured with multiple CA servers and multiple MPS servers. And on our HRA, we configure our CAs in the prioritised list. Our MPS servers, we configure a priority and a weighting. We can have multiple MPS servers at the same priority, and the HRA will load balance across those different MPS servers. So we just click through, we'll see that we have failed connections, and it connects to the next one. A lot of businesses don't just have one site, though. They have multiple data centres. We can have multiple sets of NAP infrastructure and have the client connect to its closest site. We do that via SRV records and doing an auto lookup for AD.
So from a configuration management point of view, the config manager system health validator is a site role that we deploy from the config manager console to an NPS server. Once we do that, when we tag certain Windows updates for NAP evaluation, that generates a statement of health, not a statement of health, I always get that wrong, a state health reference.
That's the one.
That get written to Active Directory and also get added to the config manager client policy. The Shiv reads the statement of health, the other one, the state health reference, reads the state health reference from AD, and now it's aware of the latest config manager configuration that is required to be available for the client as well. So when the client sends its statement of health, that state health reference needs to match for the client to be healthy.
So let's jump that up in a little thing, Rand, so we can see what's happening.
Yeah. So in Config Manager, I've created a NAP policy that generated that state health reference, which are saved to AD and to our policy. It's get downloaded to our NPS server and also to the client as part of the Config Manager policy. The client evaluates itself and it says, I'm happy to go. I've got all the Windows update that I need to be evaluated for NAP already installed. I'm healthy. That configuration is sent to the NPS, and the NPS validates that configuration and provides the client with its certificate.
What happens if I've been off the network for a couple of days, Rand, and I turn up? I've just, flown back from Australia or something.
Right, so we connect to the network. We send our old health state reference back. So maybe from a Windows shift, we're compliant, but we still have our old reference number.
So Config Manager hasn't gone and updated its policy at the moment. We all know Config Manager can take a little while to update itself.
That's right. So we send a state health reference, a system health reference to an NPS. The NPS compares the state health reference and says, you've got an older health state reference, you're not compliant. And the client says, oops, I'm not compliant, and revokes its certificates. Part of the non-compliant state health reference, system of health response, sorry, I always get it wrong, you just have to bear with me, is the remediation action to say you need to download the latest policy from your management point. From a placing point of view, we put all the config manager components in the boundary site, so we contain all the config manager traffic as close to the client as possible.
Well, we're unhealthy at this point. We don't have an IPsec certificate. We can't talk to things in the isolation zone, so we have to talk to something in the boundary zone.
That's right. The new policy has the list of the fact that there are some new Windows updates that need to be tagged for NAP evaluation. The client does its evaluation, says, oops, I'm missing some Windows update. Oh, by the way, I've got a Windows update package ready to be downloaded. The client downloads the Windows updates, installs them, does the scanning, the re-evaluation of the Windows update. It now has the latest statement of health response or the state health reference and sends the new SOH to the NPS. This time, the responses match, and the client is happy again and can connect.
You're right. Just before we dive into the actual configuration, we just want to go through the deployment phases. Now, the reason for that, next slide, is that there are some changes we make to the policy as we move through our different deployment phases. Now, why do we have these three different phases? You don't want to deploy NAP out in enforcement and then find that none of your clients are going to be compliant with your policy. It's not going to lead to a good customer experience. So what we do is we put NAP into a reporting mode first. We go into our NAP policies and we set all of our unhealthy policies to tell the client that it's healthy. Now, the clients are all good. They go, yep, I'm all healthy, fantastic. Users don't get any pop-ups. They don't really know anything that's happening at the moment. But we can look at our event logs and we can check to see how many of our clients are matching our unhealthy policies. So are our policies working? Are our updates going out? Now, when we're happy that most of our clients are hitting our healthy policies, that we've got our client fleet up to the right level, then we then move to deferred enforcement mode. We've got two options here. Now, remember, we haven't deployed our IPsec policies at this point. So deferred enforcement clients, if they're unhealthy, they now get a pop-up that says, you're unhealthy. They now try and remediate themselves. But if they can't remediate themselves, they're not going to be blocked from accessing the resources. So this is a great step to get your service centres and your operational staff starting to get up to speed with what's going to happen and get your users used to the experience that potentially, if they've been away for a couple of weeks, there's going to be a delay before they can get access to the network while the machine becomes unhealthy, while the machine becomes healthy. Then we move to our enforcement phase. That's when we deploy our IPsec policies and we enforce the health status. Once those IPsec policies are out there, if you don't have the right certificate, you're not getting access to servers in our isolation zone. Right, so the next bit, we're going to jump into configuration our demo environment. In our slide pack, there's a whole lot of hidden slides, so when you download it, it should give you enough screenshots to be able to jog your memory as to what we did.
Yep. So
we're going to talk about, look at Active Directory, our certificate authorities, MPS roles, and our config manager roles.
So where do we start from?
So I'm going to lean over Rand's shoulder a little bit here to give myself some hints.
We buddies.
We're going to jump into our NAP client GPO.
Yep, so you've got the group policy management console here, and I've opened up our NAP client policy, which can be applied to either security groups, or to OUs. So it's up to you whether you want to deploy, how do you want to concentrate your clients, whether you want to use security groups or OUs.
But not sites, as we were told yesterday. Right, so what we want to do is we want to enable the NAP enforcers that we want to be running on our network, on our clients.
Yeah, so we go down to our computer configuration policies, Windows settings, security settings, and down the bottom you will see the network access protection policies. And one of the components in the NAP client configuration is the enforcement clients.
Now, can everybody see that okay? There we go.
So as you can see, we've enabled the IPsec relaying party. The other ones refer to obviously different types of NAP that you can, different NAP options that you can implement.
Right, the next thing we want to do is we can customize the UI just a little bit. We can put our company's graphic in the pop-up, which pops up. We can change the title, and we can give them a URL to go to find out more information. But the most important thing for us is our health registry authorities. Now, in here it's called Trusted HRA Servers. This is where we specify the list of HRA servers that we want the client to be able to connect to, and the order we want them to connect to in. Don't worry about trying to write down the whole big DLL. Just jump on TechNet, do a search. There's a nice little walkthrough there which gives all of that information. Yeah.
Another option is automatic discovery, whereby you add your list of HRA servers to DNS as SRV records, and you set up a registry key on the clients to enable that auto-discovery.
Yep. Now, we also need to make sure that we've turned on the NAP service, so it's set to start, and on Vista and Windows 7 that we've set the Windows Security Center to be enabled as well.
Yeah, and that's done again in the GPO.
Right. Let's check my notes. HRA. If we go into the HRA now, Rand. Oh no, sorry, mate. IPsec policies. We almost missed it.
So IPsec policies are done on the Windows Firewall with Advanced Policy GPO. So let's edit our policy and go into our Windows Firewall. Again, policies, Windows settings, security, and Windows Firewall with Advanced Security policies.
So just under our inbound and outbound rules, we have a folder which is connection security rules. He says, squinting. How can you read that, mate?
Easy.
We go to properties on there. Okay. So if we go into our authentication, In our demo environment, we've said all ports everywhere, always try and do IPsec. So there are two really important things here. Under the requirements, at the moment we've got request inbound and outbound. That means this is a boundary policy for us. If this was an isolation policy, we'd have require inbound and request outbound. We never set require inbound and outbound. If you do that, bad things will happen, and you'll stop talking to domain controllers and nasty things like that. The other thing we have is the method of authentication. So we go advanced, and we go into our customize. Now what we're setting in here, if we go and edit that so we can see it, we're setting that we want to use a certificate authority. We set the CA that we want to be the issuing CA, and we check the accept only health certificates. It's really important we check that box. If we've got multiple CAs, you can choose the root CA that those sub-CAs are from.
Yep. Next we go to our CA.
Our HRA.
HRA. So the HRA configuration is done under NPS because the HRA is actually a component of the NPS. So when you deploy an HRA, you're actually deploying an NPS with the HRA subsystem.
And when you choose the HRA role, you actually get a local NPS server installed as well. But we don't recommend doing that. We recommend having an NPS server in the core of your network because you're probably going to want to have multiple HRAs and potentially multiple NPS servers. So what we need to do on that local NPS server is we actually need to configure it to forward requests to our central NPS server. So this is standard radius. So essentially what we do is we set up a radius group and we set a server that it's going to connect to. And we talked about we could have multiple NPS servers and we have priorities and weightings to balance across. Then we need to set a connection request policy. We need to tell this NPS to forward those requests on. So we go in here, just go back to the overview. Most important thing here is the type of server. We need to say that it's an HRA. It tells it how to process the request which has come in. And then under settings, under authentication, we need to tell it to forward these requests on. Now, on our HRA, the only thing we actually configure is the CAs the HRA is going to talk to. Now, if we go to properties for that, Ram.
I'm sure we can do that.
We'll just find it on the screen. Okay, a couple of really important things under the properties. The first thing is essentially how long we wait till we say a CA has become unavailable and we fail over to the next CA. The next one is how long we're going to issue client health certificates for. So this is different than the lifetime of the certificate set in the template, which we'll see in a minute. This is the lifetime of the certificate that a client's going to get. Now, Microsoft is currently running 3 days.
Yeah.
Yep.
Yeah.
And 3 days was about right for us. It can be shorter, it can be longer. You need to look at the risk and how quickly you're trying to enforce these things. The other really important thing is if you're running an enterprise CA, you need to specify the templates, the certificate templates that it should use. If it's a standard CA, you don't need to. If you've got a mix, you have to specify it.
Yeah, and the other thing, the important thing you need to do, you need to enable the CA to provision certificates with a shorter lifetime than the template that you're issuing from.
Yep, there's a command in our slide deck, no big long thing, which you run on the CA, and that allows that certificate time frame to be changed. But it's only for enterprise CAs you have to worry about.
Yeah, otherwise you'll be provisioning 1 year long certificates as opposed to 3 days, which you're intending to.
Right, if we jump into the CA.
Yep, sorry.
This is phone a friend.
Yeah.
While Rad's doing that,
yeah,
and figuring out where he is, on our CA...
I've lost my console, sorry. Here we go.
There you go. There are a couple of things we need to do on our CA. The first thing is we need to make sure our certificate template is configured correctly.
Yeah, you got there.
So you need to create the certificate template yourself. We're not going to go into how, we don't have the time. on TechNet it shows you the right template to copy, but there's a couple of key things that you want to make sure. If we just go back to all right, we're going to go into there first, that's okay. You need to make sure that you have the System Health Authentication OID configured correctly. Okay, if you get this number wrong, none of the rest of your NAP infrastructure is going to see that certificate as a health certificate. It's amazing the number of times you can get it wrong if you're not concentrating, isn't that right, Rand?
Yeah, absolutely.
So you want to be really careful that you get that right. Now the other thing you need to be really careful about is get the security on this template correct. So if we go into the security, okay, remember we talked about our health exemption group, and we talked about that servers in our health exemption group needed to be able to auto-enroll for that certificate. So we need to ensure that our template gives them access to be able to do that. So they need, read and auto-enroll,
yeah,
and enroll as well. Now if we just go to the General tab, Ren, and we zoom in on that General tab, you'll see here that the template lifetime is actually 1 year and the auto-renewal is 6 weeks. That's what the servers in our health exemption policy get for those certs. But it's not what the HRA issues. We set that on the HRA. Now the last thing we need to do is we need to make sure that the HRA has appropriate rights on the CA to be able to issue and manage these certificates. So we go to our CA, we go to properties and we go to security on our CA. And it's the machine account for the HRA which is used. And essentially we need to give it full access to that sub-CA. So that's going to be able to issue certificates. It's also going to remove certificates which have expired. Now that's really important, but otherwise you're going to start running out of space. So, I mean, Rand and I managed to issue 8,000 certificates to one PC over a 3-day weekend. We were checking our net compliance every minute, but you can issue a heck of a lot of certificates if you're not careful. Right, let's jump onto the MPS server, Rand.
Yep.
And we'll jump down and we'll go and look at our remediation server groups first down the bottom. So we're going to build this from the base up. So the first thing we've got is these remediation server groups that we talked about. Essentially, these are groupings of remediation servers. We can only have one remediation server group per NAP policy. So what we want to do is we want to group the remediation servers, which are going to be local to a site, into a group, and then we target our NAP policy and say, if a client statement of health request has come through this HRA, we're going to provide it this list of local remediation servers. So then we want to look at our system health validators. So our system health validators, these are the shivs which have been installed on this MPS server, on this NAP server. If you've got multiple policy servers, you need to make sure you install the shivs on all of them. Now, some of the shivs have configuration settings, some don't. The Windows shiv, we can have multiple policies, and each of those policies we can turn off different parts or different things that we're going to be looking at. In this case, the Windows shiv, we can look at the firewall, the antivirus, the spyware. The config manager shiv, we can't change any of the settings in that. Those settings are set within config manager. This is essentially just a proxy for the MPS server to get that policy.
Yeah, and as you can see, if you try to go to properties, it's all grayed out. There's nothing you can do here.
Right, so then we go into our health policies. So we're building this up, okay? So under our health policies, this is where we pull our different shivs together and we say, this is what it looks like to be healthy, or this is what it looks like to be unhealthy. So if we can go into one of those, okay? So you see, we give it a name, we say what's supposed to happen, a client fails one or more of these checks, and which are the shivs that we want to validate against, and which of the settings within that shiv. So config manager, we only have one. With the Windows one, we could have multiple settings within it. Remember, we're not applying anything to clients yet. This is just building these policies up. So then we go into our network policies, and this is where we start saying, matching our policies to our clients that are coming in. So if we go to one of our policies. So the first thing, and I'll point it out here, is the grant access. If you just scroll down a little bit, okay? This is nothing to do with the health status of our client. This is part of the Radius subsystem that we're working in. All of our NAP policies for HRA are set to grant access. So if we set it to deny access, the HRA doesn't know how to process the request and comes up with you have a configuration error. It's really hard to debug a generic problem like that. So just be aware, if it's an HRA, it's always grant access on this screen. We'll show you the screen where you tell the client whether it's healthy or unhealthy. And obviously the important policy enabled section as well. Yeah. So if we go to our conditions, this is where we say what's going to match this policy. So in this case, we're saying that the client has to be in a specific group and it's got to match the specific health policy. Now these policies are in a prioritised list and it evaluates them in that list. So we want our most specific policies at the top of the list and our generic policies at the bottom of the list.
Yeah. So in this case, we're looking for a non-compliant policy.
Yep. Now if we go across to constraints or
Yep.
We don't really change anything in here, but we need to be really careful. Just zoom out just a little bit. Under our authentication methods, the default when you go to create a policy is actually PAP and CHAP are turned on. You need to turn those off and just make sure that you've got ticked the bottom there, perform Windows machine health checks only. If you have PAP and CHAP turned on, the HRA can't process the request. So under our settings, and we go to our NAP enforcement, this is where we tell the client, this is what it means to you if you've matched this policy. Yeah. So in this case, we're saying you're only allowed limited access. We're going to pass it a group of remediation servers to connect to. And really importantly, we're going to tick the auto remediate box. Yeah, so this is the remediation servers.
Yeah,
we can also give it a specific URL if it's matched that policy. So if it's said your Shiv client's not installed, we can pass a specific URL so when the user clicks on it, that tells them, well, actually, you've managed to do this, call the service centre up, have a chat to them. So those are our policies, but we're still not quite there yet, okay? We need to tell the MPS server to process these requests locally. So just like we did on our local MPS, on our remote MPS, we need to do the matching policy, but under our settings, under authentication, we need to say, authenticate these requests locally, okay? Now, because we're using Radius, we need to tell the Radius server to accept connection requests from our HRAs. So if we go up into our Radius clients this time, we configure each of the HRAs that are allowed to connect to us, and just like we did on our MPS with our server groups, we configure the reverse side and put in the shared secret and say these are allowed to connect to this network policy server. Right. Config Manager. How does that integrate with the rest of this, Ran?
So as we said, all the configuration for the Config Manager Shiv is done in the Config Manager console. The first thing I need to do is deploy the system health validator point on an NPS. Once I do that, I need to go to my client agent and enable the network access protection client agent. So I need to tick that box, and I need to determine how often does that Config Manager SHA on the machine that we're evaluating is actually going through the evaluation. And we can set or force the client to do a full Windows Update evaluation every time that time elapses.
This is kind of a key setting. If we force that, every time a client detects it needs to check its state, it's actually going to try and connect to the Config Manager server and do a quick scan. So that can lead to a delay in clients connecting to the network, but it can also reduce clients getting told they're unhealthy and then having to do a scan and then becoming healthy again. So you need to tune that for your network and how far away your clients are from your Config Manager servers.
Yeah, and here also you set up how often do you want the client to go through the evaluation of Windows Update and see if there's any which are enabled for NAP evaluation. So the longer you keep that, the less pop-ups the user is going to get, the less chance it is that they're going to be disconnected from the network if they're not compliant. Once we enable the client, we need to go and pick up Windows Updates for NAP evaluation. We can do that by selecting the Windows Update that we've downloaded, go into the properties of each of those Windows Updates and select the NAP evaluation tag. Once I enable that, that will generate a new NAP policy, a new state health reference that will then be copied into, written into AD and picked up by the Shiv.
Now this is in addition to the Config Manager settings already. So what we're trying to catch here is we're trying to catch clients which have been off the network, they've been away for 3 days, they haven't got the policy, they're past the deadline that we've set in Config Manager for that client to be, for that application to be installed, and we're now saying, we gave you a day's grace, but now it has to be installed before you can get onto the network. So we're forcing that, and we're trying to get around that 2 or 3 hour delay that clients can have updating their policy from Config Manager.
Yeah. Another way of enabling NAP policies in Config Manager is to go to the Network Access Protection Hive here and policies And here you'll see the list of Windows updates which are available to you. And to create new ones, you right-click, new policies. These are all the Windows updates which have been downloaded. And you can just select the ones you want, go next. That will tag them for evaluation and on the next evaluation cycle that the client is going to run through.
Right. Ooh, we're chucking through the time, Ren. So let's jump back into our slides. Okay, this is really just a reference slide for you to when you download the pack. The takeaway from this is timing is everything. Just be aware of the impact of changing some of these timers. If you wind back your client NAP evaluation schedule to once every minute, as Ran and I did, you are going to reevaluate your health status every minute and generate 8,000 certificates per client. So tune these as to what works for your network, and I guess, a warning there. Okay, so just recapping the sort of staged implementation approach that we've talked about. Our recommendation is the first thing you do is you get your CA servers installed and configured. Okay? The next thing you do is deploy your health exemption policy, get your servers into the security groups. They're going to need a restart before they get their certs, and make sure that your exemption servers have those certificates on them. Next thing, get your HRA, your NPS, and your remediation servers deployed. Okay? Then set your NPS policies to reporting mode and deploy the client group policy. Once you're happy that your clients are reasonably healthy and things are working, then go to deferred enforcement, and then once you're happy with that, then hit your IPsec policies out there and enforce that. And remember, if you run into problems, you can always roll back.
Yeah.
Right, we're going to whip through these slides really quickly because they're more reference for you.
Yeah. So when we said, how do you need to and only enable the IPsec isolation policies once you know your client are healthy? How do you know? By tracing the event logs and tracing the auditing information that the NPS and HRAs are writing to their accounting and tracing logs.
Those logs are really verbose. So if you just go to the next slide, Ran. So what Ran and I have found been quite successful is just using PowerShell to extract out the parts of the log that you want and just export that out to an HTML file. Now we can schedule that and we can push that up onto a web server. Our service guys can have a look at that. It saves a good 40-line message log trying to pull out the bits that you need.
Yeah. We also save everything to a text file as well as a SQL. So you can use that information in the SQL database to create fancy reports if you like. And of course, with SCOM, Ops Manager as we like to call it, you can add your own monitors and rules to collect and view those specific events.
So there's the link for the MOM pack, if you want to grab the MOM pack.
Yeah, or you can create your own Ops Manager little management pack for NPS. Unfortunately, we don't have one for Ops Manager 2007.
We thought you might like this one. This is Microsoft's internal structure for NAP. It's probably a little bit overkill for quite a lot of places in New Zealand, but scales.
Yeah, because we have distributed NPS environment. We log everything to a local SQL Express database that then gets replicated to a middle-tier SQL server from which we run reports using reporting server. If you have a large amount of clients, at Microsoft you're looking at over 100,000 clients. We do need to know what's going on, so we have a fairly robust reporting infrastructure. If your network is smaller, obviously you don't want to go to that level of detail.
We'll pass you the dodgy PowerShell script afterwards.
Yeah. So here's all the events that you can look for. That PowerShell looks for the specific event that says client compliant, non-compliant.
The two bold ones are the ones you're going to see most often.
Yeah.
6272, 6276. The other ones generally mean you've probably got a configuration error somewhere in your system.
Yeah. So from an edge array point of view, you'll see alerts if the edge array cannot connect to the CA or cannot connect to an NPS, or if it cannot validate workstation, which can happen if the workstation get deleted from AD.
We
happens
when we broke our demo. On our CA, the key things there, just make sure the security is correct, make sure the HRA can connect to the CA, confirm the CA actually has the certificate template, and that the CA can see its the route, and that's all working correctly. Not a whole lot on the CA that you can break, really.
On the NAP client, some commands you can run. NAPstat initiates the NAP client pop-up balloon. By default, it's hidden. So if the machine is compliant, users don't see anything. If the machine is not compliant, the balloon will pop up. If you want to see what's going on, you can just type netstat and that balloon will pop up. There's a whole bunch of netsh commands that will show you the specific configuration.
If we manage to get through the end, we'll show you some of these
in
the last little bit.
Yeah. One important thing around the client configuration, if you wonder what's going on and why is the client not behaving the way you expect, perhaps it's looking at a different network protection server that you expect, and maybe your configuration policies are not consistent.
Yep. So just with your IPsec, if your client says it's all happy and it says it's healthy, check to make sure it's got a certificate. You've got to check in the machine portion of the certificate MMC under personal. If it doesn't have a certificate, it's not going to be able to create IPsec associations. Also, if it's got a certificate, jump on the client on one of your isolation servers, make sure that the security connection policies are the same, that they look right. Check your connection security rules as well. If you're using null encapsulation, you also need to check to make sure your Windows firewall is configured for null encapsulation too. So we'll just skip through that bit, and we thought it might be good just to go over the lessons learned first, and then we'll jump into the last demo. Okay, so we talked about HRA should never receive a radius deny from an MPS server. If it receives a radius deny, it just comes up with a really helpful there's a configuration error and stops. So it should never receive a radius deny. Test connectivity in both directions. Now, remember these IPsec policies, right? We've got a request inbound and outbound on our boundary side, and we've got a require inbound and a request outbound on our isolation side. If we try to make a connection from an isolation server to a boundary server and IPsec fails, it's going to fail back to unencrypted because it's going to go, well, I'll just request that connection, and the boundary goes, well, it's only a request, that's fine. So always confirm connectivity from boundary to isolation servers, from isolation to isolation servers, boundary to boundary servers. Don't just do, as Ran and I did, isolation to boundary and go, yeah, yes, awesome, it all works, because you find it won't. Yeah. Use netmon to confirm the traffic is encapsulated as expected. Okay? Jump in there, look at the packets, confirm if it's null encapsulation or if you're just doing AH headers, make sure that that's what's happening. Don't rely on ICMP and ping. ICMP is treated differently. When you go into the configuration screens, you'll see there's actually a checkbox to say exempt ICMP from IPsec. Just because you can ping it doesn't mean that you're creating an IPsec association. Okay, so we recommend use NetView, use SMB, browse the file share, make sure you can get a proper connection to the box. And while you're there, copy a large file across. Make sure that the bandwidth that you're seeing is the same as or close to what you were getting prior to applying your IPsec policies. Okay? Just back to Dylan, just for a second.
If you insist.
You're too quick. There's two others here. I'm going to lock all my PCs out of the network. I'm going to set a policy, I'm going to go home, and I'm going to come in the morning, and no one can connect. Well, yeah, if you get it wrong, and that's why you have change control, and that's why we test these things, and that's why we have test environments. But also, it's not a dead end. It's very easy to detune your policies and get everybody healthy again. So if you do set a policy, or say you've got a virus definition update problem where the virus definitions haven't propagated out to the right servers and clients can't update themselves, you can go in, you can change that policy, deselect that shiv for the 12 hours you need to fix the fault. Your clients don't have to stay unhealthy. You don't have to shut down your NAP infrastructure while you're trying to do that. You can very quickly detune it to get things healthy again. And we do recommend having a resilient setup, have multiple HRAs, multiple MPSs. They can all be virtualized in their very small roles. Don't do require inbound and outbound on your IPsec policies, okay? If you can't talk to an AD server to get group policy, you can't get back out of that. So as Ran and I did, you just end up dropping machines off the network and rebuilding it. So be very careful on that.
It's called chopping the branch you're sitting on.
Yeah, big time, big time. If you've got multiple MPS servers, choose one as the master server. Set that and always do your policy configuration on that server, and then use the NetSH export and import commands to export that configuration and import it on your other servers. you run the risk of getting into a situation where you have subtly different policies on two MPS servers. Clients fail over between the two, and you can't figure out why sometimes it's healthy and sometimes it's unhealthy and what's going on. Now, we reckon you could probably use PowerShell remoting to sort of automate that quite a bit.
Yep.
Now, this KB article, if you're thinking about doing null encapsulation, you need to pull down this hotfix. It was released 5 days ago. Rand and I have been testing the private hotfix for the last 4 months now. It addresses a performance issue with the IPsec path that it takes through the stack. So it's really important to have that policy if you need to go null encapsulation.
Yeah,
We've got
so
5 minutes, Rand.
we
can
do.
show some of the demo.
Very hooray. So on the client side, some of the things we can do. Oops. Hey, we use trial keys just like everyone.
I was at a demo yesterday and they went to fire up 1,000 desktops, and they all came up saying license key had expired, and the guy was like, it was working 28 minutes ago. He looked at his clock and it was like 12:27 or something on the clock that just expired.
So,
Run napstat.
yeah, so as you can see, I don't have any bubbles on the bottom here. If I'll run napstat, that will fire up the bubble. If I'll double click on the bubble, I'll see some more information written behind here that suggests that I'm compliant. On this client, I only have the Windows Windows SHA enabled. The other client, I had the config manager one as well.
If you run napstat and you get a really nice looking box with nothing in it, that means your client hasn't been able to connect to an HRA or potentially doesn't have any policy down. So if you see a nice blank box, there's problems somewhere. If your client's dropped off the domain because you deleted the OU by mistake, then you'll have a similar issue as well.
Another very important command, netsh nap client show state, not start, sorry.
Ooh, we could try start. I don't know if it'll work.
Shows you the configuration of the shivs on the machine. And here I actually have two SHAs on the machine. Sorry, one is the Windows client and the other one is the config manager one. And it tells me the state of the SHAs and whether they're compliant. So we've got additional commands in the slide deck. You're more than welcome to plagiarize and use as required. So some more information on config manager and NAP, more information on step-by-step deployment guide for NAP with IPsec. Please go try that in your environment. You'll find it's very, very compelling story from a security and a compliance point of view.
Hey, thank you all for coming. It's been really great. Please remember to fill out the evaluation forms. Both Rand and I would like to come back next year.
That's right.
Apparently, we've got to get good evaluation forms. We've got some business cards up the front. Happy to, if you want to email us or ask us any questions.
Why is your stack bigger than mine?
Well, I don't know. I'm a consultant. And if anybody's got any questions, why don't you come up the front, because I know there'll be some of you that want to dive out and get to the front of the lunch queues, and we'll be here for the next 20, 15 minutes. Happy to answer any questions. There was a lot of learning. So,
yeah, one of the main issues we had was the performance issue, and we used Ping as our testing, diagnostic tool, and obviously that proved to be bad. Once we started doing some data transfer, we realized we did have a networking issue, and turning off TCP offload was not a really good solution. So by the time you get a hotfix, that takes a while.
So let's answer that question another way. How long would it take us now? So reality is it's a couple of hours once you know what you're doing. These are all standard roles, very easy to install. The group policies are very simple. There's only a couple of settings in there. And then you're just going to set up your policies, which again aren't a big thing to do. And even if you just run reporting mode, there's a whole lot of intelligence that you can get. And that was one of the learnings from Microsoft internally, wasn't it?
Yeah.
That even reporting mode, there was a fantastic amount of information. They could go back to the business and say, we've got laptops that aren't updating for months and months.
Yeah,
we've got serious issues here.
That's right. Setting it up, doing the technology, clicking the buttons is one aspect. You've got to start with talking with the business, understand why do you want to deploy that to begin with. What settings do you want to enforce? what the impact of locking your CEO if he's in a conference overseas and he suddenly can't connect to the network.
Now,
because
just on that, you did see how we matched to a security group. We do recommend that you will have times when you need to match 1 or 2 machines to a specific security group and make them healthy, just because the business accepts that risk. Because, yeah, you do end up with, if your CEO's overseas and he's trying to pull the massive, great big,
Windows update.
Yeah, and he's got a big deal on, you do have to accept that you're going to have exceptions to some of this stuff. But you can do it in a way where it's only 1 machine or 2 machines, not your whole network suddenly gets access because you needed to detune your NAP infrastructure.
And if you're running in reporting mode long enough, you'll start to identify patterns of certain machines, and you can track them and see how long it takes a machine to remediate, etc.
Were there any other questions?